In action. Hey, we're back. I figured out how to do long division. I was really close. So if you just watched that last video, if you didn't watch it, you should watch the introduction video first, where I kind of gave you the background. And where it all ended was doing long division with polynomials. So I just want to remind you real quick with just long division in general, like go back to like 5th grade or whenever you learn this stuff. Remember what you do is you have a number, I forgot if you call it the quotient, something like that, and then you have a divisor or whatever. So I'm going to divide 7 into 32. I'm going to get 4. I'm going to do the whole multiplication thing. I'm going to have a number left over. That's my remainder. So when you have a remainder, that means that 7 is not a factor of 32, right? Because there's a remainder. If the remainder is 0, like 8 into 32 is 4. 4 times 8 is 32. That means that 8 is a factor. So 8 times 4 will bring you back to 32, whereas 7 times 4 will not bring you to 32. You have a remainder. So that same idea applies for dividing by polynomials. So let's just kind of work our way through this. The first thing is we're dividing this big old polynomial by this linear term. Linear because it only has x to the first. And once again, where did this come from? They told us in section 3, you're not expected to figure out a term off the top of your head that might work. They're going to tell you, try this term, divide it, see if it works. See if when I say it works, in other words, see if there's a remainder or not. If there's no remainder, then it's a factor, and you got a good term. So let's just go through the process here. So I wrote the original polynomial, and I had to fill in a 0x squared because notice there's no x squared term. So just like synthetic substitution, if you're missing an x, you put a 0 in there for the place value. And then I'm going to look at the very first highest order term, and I'm going to divide that into them. So 2x goes into 4x cubed 2x squared. And I had that part right from the last video. Now you just stop with that, and then you multiply everything. So, and remember what you're doing. You're multiplying the terms, so it's like distributing it. 2x squared times 2x is, of course, 4x cubed. That's the whole point, right, to cross those out. But you also have to remember to do this. 2x squared times 5 is going to be 10x squared. Now you can subtract it. These terms cross off. I'm going to have a negative 10x squared. And now I'm going to have to divide it again. So 2x goes into negative 10x squared, negative 5x times. Negative 5 times that is negative 10x squared. And then negative 5 times 5 is negative 25x. And then subtract, right? So that negative becomes a positive. Those cancel off. This becomes a positive. So it's 25x positive and negative 31, which would be negative 6x. And then 2x goes into negative 6x, negative 3. Negative 3 times 2 is negative 6. Negative 3 times 5, look at that, negative 15. It's a beautiful thing. Then when you subtract, they cancel off. That turns into a positive 15 and negative 15. They cancel off too. So in other words, there's no remainder. So once again, think about what that means. That means when I took this seemed kind of random, but obviously it was well picked out. I took this linear term, I long divided it into this big old polynomial, and I got a second term, which happens to be a quadratic, because it's squared, and there's nothing left over, there's no remainder. So that it's just like this problem. 8 into 32 is 4 with no remainder. So therefore, this times this is going to bring me back to here. So that means I can take this term, multiply it by this big old term, like this, and it will bring me back to the original problem. And so what? What good is that? Well, the good thing is now you have a quadratic, and you know how to factor a quadratic. You could use completing the square, or you could use quadratic formula, or you could use your diamond method, whatever you want to do. But you can factor that quadratic, and you can get 2 answers. And then you can get an answer from here. Because you can set, when I say an answer, I'm talking about set it equal to 0. 2x plus 5 equals 0. 2x equals negative 5. x equals negative 5 halves. In other words, when x is negative 5 halves, that turns to 0. This times this is 0. So the whole polynomial equals 0. You found one of the roots, which brings you all the way back to where we began when you're drawing your little graph. I'm just going to draw it right here. I know one of my solutions is going to be negative 5 halves. So when x is like right about here, my polynomial is going to cross the x-axis. So now we're going from where we were before, we were just sketching the graph, we were just kind of generally, now we're going to exactly crossing the axis at the exact point because we've determined the root. And we would find the other two roots when we factor this quadratic. So there's your long division process. Now you're going to go practice it with the first 6 problems. And then you're also going to learn synthetic division, which is the same kind of thing, but where you just get rid of all the x's. So I'll make another video for that. But work on this first. Namaste.